Now we'll see some assumptions of WSM. Okay, so the first assumption is plane bending. Plane section will remain plane after bending. Okay, after bending. It's a common assumption. Why they are doing this? Because the strain only in this case, and the strain will be proportional to y. Okay, the stress will be linearly varying otherwise. So it's basically assumption. Okay, it's basically the basic assumption from you have seen. This assumption is bending stresses that we are dealing in. So on the basis of that, we basically can derive this equation that the stress is m by I into y. So this is basically based on this assumption. This okay. So if we are not considering this assumption, then this is not valid at all. Okay. So how we can use this assumption now, as we have now used this, how we can use this assumption, how we can use this assumption now. Okay, so plane section will remain plane after bending. How we can use this basically, so like this. So if we have this section, if we have this section, let's go, okay, and this will be its strain diagram. With this strain diagram, and strain will be same in case of concrete as well as strain will be same in concrete and steel, whatever level we take. Okay, okay. And this is the stress. This is CA. Okay, so let's put this is Y1 here. This is Y2 and this is Y3. This is CA. This is FCBT. Okay, and this is F3. TA by M serial. Okay, so how we can use this? Let's suppose this is the strain in concrete, strain in tensile side of concrete, and this is strain in steel in tension. Okay, how we can use this? Basically, similar triangles, simple as simple as that. Similar triangle, okay? Similar triangles we can use. Similar triangles we can use. Basically, if this is y1 and this is y2 and this is y3, basically E of concrete divided by y1 will be E of concrete in tension side divided by y3. Simply will be equal in steel divided by y2. Okay. So this is basically the strain. But in case of the stress, we can write like this. So we here we write directly the value of the strain in the steel, okay? Because they are equal basically, okay? So here we can write like this: FCBT divided by Y2 is equal to TA by M divided by, because this diagram is for concrete. This is also for concrete, but the values are same divided by basically this is Y3 and this is Y2. Okay, right? So, okay. So this is how we can use this diagram. This is how we can use this diagram. Okay. This is how we can use this diagram. So what is next assumption is that all tensile stresses are taken by steel only and none by the concrete. Very important. All tensile stresses are taken by steel only and none by concrete.
and none by concrete. So basically, what we are saying that this is about the cracked section, right? It's about the cracked section as we are saying that nothing is taken by concrete. So basically, the concrete has lost its field. So this is cracked section, or we can say that FCBT, the stress on the tensile side, is greater than FCR. So the concrete is then neglected on the tensile side. Okay, it's neglected on the tensile side, meaning this. If we are like this is the concrete side, so we'll neglect the tension side. Okay, so only steel will be there. This is in case of cracked section. And similarly, y bar will be, or we can say that xu will be, or we can say the position of neutral axis will be calculated as like this. So we'll take only the steel side and that will transfer on the steel side. Okay, this is in case of cracked. If it had, it has not, but it has affected our the neutral axis if it has been an uncracked section. Okay, how? So basically, we will not ignore the concrete side on the tension side this time. So we'll have to, we'll have to consider that as well. So that will be somewhat lower. Okay, on this side we don't know. So basically, there will be little shift if we consider to the downward side. If we don't consider, there will be little shift upwards of the neutral axis. This will see later. Okay, so we'll consider we'll consider as cracked section, but sometimes if it's specially said that we have to keep it as uncracked section, that in those cases we'll see. Okay, okay. Now, if we see the stress strain relationship of concrete, okay, for concrete and steel for WSM, okay. Okay, so basically this stress strain in both the cases will take some layer, but if we see for concrete, this for concrete, okay, so some part will be linear here. That's what. Okay, so this is FCK basically linear, and we are taking the curve of FCK by 3 only. Okay, limiting our curve of FCK by 3. Basically, this is a linear part. This is linear part. This is linear part. Okay. Similarly, when we are saying for the steel, okay, for the steel, so basically this is FCK and we are limiting it to FCK by 1.8, and this is also linear. This is also linear. This is also linear. Okay, this is also linear and this is also linear. So that means the stress strain relationship we are taking in case of concrete or whatever, it's concrete or steel, that's linear. That's linear. Okay, that's why we are using this curve, this this and this as well. This and this. Okay. So the modular ratio is 280 divided by 3 sigma CDC. That means this modular ratio will depend upon the concrete and bending compression. What will be its value? Sigma CDC. And is 280 divided by 3 sigma CDC. So this is depends on FCK value, right? So what is this difference? It's basically the values it gives. It gives the value between. P short term, P long term. Okay, so this is about